So, if you are studying trigonometry, either as a standalone course or maybe part of another course like pre-calculus, and you are finding it difficult, well, you are not alone. So, don't be discouraged because there is a lot to learn. Now, in this particular video, I'm going to cover how to graph this function right here. We have y is equal to 1/2 cotangent 2x. Now, if you kind of want to do this problem with me, you might want to pause the video and see if you can come up with the sketch of the graph. But this is the type of problem that you're going to have to do at this level of advanced math. So again, even if you've done well through algebra, geometry, algebra 2, if you're taking this level of math and you're finding it difficult, well, that is perfectly normal. So don't be discouraged, and I'm going to go through a lot of details here in just 1 second. But first, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need assistance in mathematics, especially something like pre-calculus or trigonometry, then check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. Okay, now most of you out there at this level of math have a graphing calculator. So the idea here is not to plug this function into your graphing calculator and see what's going on. Now you certainly need to know how to do that, but what I'm looking for is a basic sketch. So if you have your sketch ready, so let's go ahead and take a look at the answer. So this would be the sketch, and again, if you have no idea what's going on, I'm going to explain it in just 1 second. So here is one period, okay, of this graph that we're going to be looking at. Y is equal to 1/2 cotangent. Let me just put this here. 1/2 cotangent 2x. Okay, so if you got this right, that is fantastic. Matter of fact, I'm going to give you a nice little happy face, an A plus. I'm sure you're doing very well in your class, but you just can't, do a problem like this without a lot of study and hard work. But if you are confused, you're like, yes, Mr. YouTube Math Man, this is the stuff that I really just are struggling with. I find it so difficult. Well, don't feel bad. Okay, this is not easy stuff for most students. So, but anyways, this is one period of this cotangent graph, and you can see it goes through pi over 4 right here, and then we have some critical points, pi over 8 and 3 pi over 8, and the period is pi over 2. Okay, so this is the graph of this function. How do we get this graph? Well, let's start talking about this right now. And by the way, too, this is just cotangent, okay? We have to know how to graph tangent, cosecant, secant, sine, cosine. There is a lot to learn, and this is only one particular chapter or unit in trigonometry, which is only a part of what you learned in pre-calculus. So again, I congratulate you at being at this level of mathematics. So let's go ahead and get into how to do this problem. Okay, so first things first, let's just talk about the general shape of cotangent. Now, if you don't know what cotangent is, you're like, I don't even know what you're talking about. Well, this might just be, a little bit advanced for where you're at right now. It doesn't mean you can't learn this stuff, but if you don't have a basic understanding of trigonometric functions, sine, cosine, tangent, and cotangent, secant, and cosecant, well, you need to have, that understanding before you can get into how to sketch these functions. But this is what we call a periodic function in trigonometry. So when you study trigonometry, you study something called periodic functions because they repeat. So let's take a look at one period of the cotangent x graph. So this is y equals cotangent x. It's a basic graph. Now this right here is the graph in and of itself, but it continues to repeat on and on and on. So that's why we call this a periodic function, but we're only looking at one period. Now I'm using this word here, and you can see like the width of the graph is between 0 and pi. But I have these little dotted lines here. And what do those dotted lines indicate? Well, if you said asymptote, I would say you are doing fantastic in your class. That's absolutely right. Now, what is an asymptote? So that's a little pop quiz for you. If I said define asymptote in your own words, put that into the comment section And if you said something, well, it's a line where the graph approaches but never touches, you would be absolutely correct. So I got to give you a little happy face and A plus for that answer. And this is what's going on here with this cotangent graph. It's approaching pi. Okay, so we're going from 0 to pi. Again, we're working with radians. And pi is equivalent to what? Well, 2 pi is 360 degrees, so pi is 180 degrees. So again, I'm kind of assuming that you have a pretty good knowledge of all this stuff at this level. But anyways, so the cotangent is approaching, the graph is approaching the asymptote at pi. So let's kind of go ahead and define some of these things right here. So I want to be using some terms that hopefully you understand. So we are talking about a trigonometric function. Okay, so functions have domains and range, and of course we have a period, and then this is what we call the fundamental cycle. Now let's just go ahead and define the domain. So x cannot be, okay, so basically we're talking about any real number. However, this is x cannot be k times pi, where k is any integer. What does all this crazy stuff mean right here? Well, effectively, we're talking about the period, right? So if k is any integer, let's let k equal to 1. 1 is an integer, so 1 times pi is pi. X cannot be equal to pi. So this is the x-axis. Why? Because these are the asymptotes. Now, there's other reasons for it, because when you look at the definition, the trigonometric ratio of cotangent, you can see that that is undefined. So that's why we have to kind of express the domain this way. But it's not just pi, right? It's any integer. So k can be 2. So 2 pi right over here would also not be in the domain. And that's where our asymptotes are going to be, because we're talking about x equal lines. Okay, so that is the domain. And then the range is going to be basically negative infinity to positive infinity. What does that mean? Well, it means the graph, it can go to positive infinity, and down here it can go to negative infinity. So that is the range. And let's go ahead and talk about the period. So again, we're talking about periodic functions. So if we're talking about like sine, right, the sine wave continues on and on and on. And each time it repeats its cycle, this is a period of that graph. Okay, so again, we're talking about trigonometric periodic functions. So the period here is pi units. Okay, so it's pi wide. So here, from here to here, the graph is going from 0 to pi, and then of course it would repeat on and on and on. Okay, and what is the fundamental cycle? Well, one cycle is just basically one complete graph. So it's going from 0 to pi, and here is our interval notation. Hopefully you understand it right here, but there you go. So 0 to pi. All right, so that's just the basic cotangent graph. Now, you might be saying to yourself, well, that's a lot to know about cotangent. Well, guess what? You are so lucky, because at this level of mathematics, you need to understand the tangent function, everything I just described, the domain, the range, the periodic function, the fundamental cycle, etc. And then you get to understand sine, cosine. You're just so lucky to be at this level of math. So that's why you have to take great notes, all right, and pay attention. This is the kind of stuff that you just can't learn by sitting down like, oh, I'll just kind of cram real quick for my exam or test. It's not going to work. You have to be committed at this level of math, and hopefully you already have those academic habits down. Okay, so let's go ahead and talk about how to sketch graphs of tangent and cotangent functions. Okay, I'm going to give you a lot of information here. I'm just going to cover it really quickly. Now, I'm going to tell you that what I'm covering, I cover in much, much more detail in my pre-calculus course. I'm going to leave a link to that in the description. I really take a deep dive and fully explain everything you need to know about what we're talking about. Okay, so I build up your knowledge. So this is just kind of a portion of what I do teach in my pre-calculus course. So if you're struggling with this, material, check out my full pre-calculus course. You'll get full, complete, comprehensive instruction and a ton of solved problems fully explained. But let's go ahead and take a look at what should be in your notes if you need to understand how to graph, tangent, cotangent, of course, secant, cosecant, sine, cosine, etc., etc. So I'm going to be covering these steps. So you can see I'm going to start with number 1, number 2, number 3, number 4, number 5. And I'm going to go through these pretty quickly. If you want to write these down for your notes, that's perfectly fine. But I'm going to go through them pretty fast because we have a lot to go here. All right, so to graph y equals tangent bx, so this is just a general form of a tangent function, or y equals a cotangent bx, okay, where b is greater than 0. And our problem right here is a cotangent problem, but this procedure applies to both cotangent and tangent. Well, here's what you need to do. Okay, so number 1, okay, the period is going to be pi over b. Again, we have these variables. A is the coefficient, which is the amplitude, and then b is this number that's in front of the x inside of the function right here, right? So this is part of our angle. So the period is going to be pi over b. And then to locate two adjacent vertical asymptotes, okay, and of course we need to find out those asymptotes because our graph is going to be between those asymptotes, we need to solve the following equations for x, okay? And remember, we have a as a variable, b and x, a, b, and x. Okay, so here we go. So we have to solve the following equations for x. So for tangent, I'll just cover tangent as well, although we're doing cotangent for this problem. Y equals a tangent bx. Bx is going to be equal to negative pi over 2, and bx is going to be equal to pi over 2. Remember, we're going to be solving these equations for x. And then for cotangent, we're going to be solving bx is equal to 0. We're going to be solving for the variable x again, and bx is equal to pi. Again, b is the value that is in front of x. All right, so now let's move on to the second step. Boy, isn't this is just so exciting. And if you love this stuff, I mean, it's going to be awesome when you get into calculus and everything. But listen, you are obviously extremely smart and you love math, or you wouldn't be watching this video. All right, so step number 2, we're going to sketch the vertical asymptotes from step 1. So we need to figure out the asymptotes, okay? So the asymptotes are going to be x equal lines, right? So these are going to be the lines because we need to kind of structure where is the graph going to go. So the first step is to figure out the asymptotes, and to figure out the asymptotes, we got to solve these equations for x, and then we're going to sketch those asymptotes. Then what we're going to do is we're going to divide the interval formed by those vertical asymptotes into 4 equal parts. So we got to divide by 4. And when you are dealing with pi and these numbers like that, sometimes students get confused. And guess what? We're talking about basic fractions. So yes, indeed, even students at this level can struggle even with basic fractions, but no big deal. Let's move on to our fourth step. We need to evaluate the function for x found those values found in step 3. Okay, so we're going to come up with 4 equal parts here. So we have our asymptotes, and then we're going to divide this into 4 sections. And then from each of these sections, we need to evaluate the function for those values. I'll show you what I'm talking about here in a second. But again, if you are a trigonometry student or a pre-calculus student or just at this level of math, you should have a sense of what I'm talking about. Okay, so step number 5, what we're going to do is sketch a smooth curve through the points found in step 4, and then we're going to indicate the curve is approaching the vertical asymptote. So your teacher, okay, wants to see that you understand the behavior of a graph approaching an asymptote. So you don't want to ever touch the asymptote when you're graphing, and you need to indicate that your graph is approaching but not touching that asymptote, okay, showing that asymptotic behavior. All right, so if this makes sense, let's go ahead and do this example. But before we do that, I need you to do something for me real quick. Hit that subscribe button because putting this together requires work. Now, it's the kind of work that I love because I love teaching mathematics, and particularly I love to teach people that are having a difficult time with math. Now, it is very normal, again, if you're at this level of math to struggle. And if you're like saying, boy, I have to work hard, for whatever reason, it's, not coming easy to me. And I'm like looking like this, my hair is coming out like that. I'm like, I don't get it. I don't get it. That is normal. So don't feel bad. What you need to do is to continue to work and study, but what you really need is comprehensive instruction, okay? And you need a lot of demonstrated examples, and that's what I love to do. So if you hit that subscribe button, it really helps my channel grow. You might as well hit that notification bell as well. And again, if you're at this level of math and you really want my best work, detailed explanation, all this stuff, you got to check out my pre-calculus course. You'll see a link to that in the description below. Okay, so let's go and do this example problem now, which of course is the problem for this video, and we're going to graph y equals 1/2 cotangent 2x. So we're going to go ahead and apply the steps that I just covered, okay? All right, so here is our general equation, y equals a cotangent bx. So the number in front of cotangent right here is going to be a, right? So that's a is equal to 1/2, and then b right here is going to be equal to 2. All right, so there is our b value, it's 2, and our a value is 1/2. Okay, so this next thing we need to do here, we need to figure out our vertical asymptotes, okay? And we also need to figure out our period as well. So the vertical asymptotes, remember, for cotangent, we need to solve the following equations. Bx is equal to 0 and bx is equal to pi. What is b? B is 2, okay? So we got to figure out 2x is equal to 0, solve for x. That's easy. X is equal to 0. And 2x is equal to pi, so x is equal to pi over 2. Okay, and the period is pi over b for cotangent. So b is 2, so the period is pi over 2. And that kind of makes sense too, because our vertical asymptote over here is pi over 2. Okay, so what do we need to do? Well, we need to go ahead and sketch our vertical asymptotes. So we have these two asymptotes here. 0, x is equal to 0 is the y-axis, and x is equal to pi over 2. Okay, so here is just kind of a real basic graph, and even if you, figured this part out, that's excellent. But what we want to do is be a little more precise. So we have our cotangent graph going approaching our vertical asymptotes. Now again, remember, this continues to go on and on, for multiple periods, and sometimes, matter of fact, very often, you'll need to graph more than one cycle in your class or on your exam, but we'll just focus on one cycle for this function. But here's cotangent, it's coming through right through the middle, right here, but remember, now we have to divide this up into 4 sections, and then we're going to have to figure out what these are, okay, on the x-axis, and we're going to basically have to come up with the location so we can draw this smooth kind of graph of cotangent, or actually the specific graph is y equals 1/2 cotangent 2x. All right, so how do we do that? Well, we need to, well, actually, let me just show you the answer. So here, when we take pi over 2 and we divide it by 2, we're going to get what? Pi over 4. Remember, we need to take our period, okay, this entire part right here, and we have to divide it by 4 to get these points. Now, you don't have to divide by 4. It's not like an absolute rule, but what we want to do is have this a nice span here to show the graph. So in other words, at this point, I have this coordinate. At this point, I have this coordinate. We know this coordinate. So, we can kind of draw, we need at least a minimum of 3 points here so I can kind of get a basic idea of the sketch. All right, so how do we do that? Well, here we go. We just create a nice table, an XY table. So we have to figure out what, when x is equal to pi over 8, what is y? Okay, so when x is equal to pi over 4, what is y? And then when x is equal to 3 pi over 8, what is y? Now, what are these values? Well, these values right here, remember, we have to take our period or the cycle and divide it by 2. Okay, so when we divide it by 2, we get this point, and then we'll just kind of divide the whole thing by 4, so we have fourths, right? So this is 1/4, 2/4, and 3/4. So these are the points. Again, we need to be able to take this pi over 2 and kind of split it up, right? So pi over 2, and we divide that by 2 is equal to pi over 2 times 1/2, which is equal to pi over 4, which is this right here. And of course, we could take that, divide that by 2, we'll get pi over 8, and then you just have to basically be able to add and subtract. Now again, I'm kind of quickly going over this because this is not complete full instruction that I would show you, let's say, for example, in my class, but hopefully you get the idea. Okay, but these are the x values. What we need now is the y value so we can have full coordinates to plot so we can have a lovely curve here or a nice cotangent graph. So when x is, for example, pi over 8, well, what do we do for that? Well, here is x, right? This is y is equal to 1/2 cotangent 2x. So I'm going to replace this x with pi over 8. So this is going to be 2 pi over 8. So now we need to know what the cotangent of 2 pi over 8 is, and that's going to be what? Pi over 4. Now, this would be a problem that you definitely would see on an exam where your teacher says no calculators, because then you're going to have to go ahead and evaluate trigonometric function for pi over 8. And, some of you out there are like, boy, this is a lot of work. Matter of fact, it might take you 20, 30 minutes to do a problem like this without the aid of a calculator. Again, perfectly normal. Okay, so it is a lot of work, no doubt about it. Okay, so here when you figure out what the cotangent of pi over 4 is, you multiply by 1/2, but the answer here is going to be 1/2. I'm not going to get into all this. It's just going to make this video too long. And you can see here I'm going to evaluate the function for pi over 4. So we replace x with pi over 4, and we'll do the same process. We'll end up with a 0 here. And then, of course, we'll evaluate for 3 pi over 8, and we'll end up with a negative 1/2. All right, so these here are our coordinates, okay, that we need to plot on our graph. And this would be a minimum kind of acceptable graph for most teachers in most classes. Okay, now I know I covered a lot, and I know a lot of you might be like this, just like, smoke coming out of your ears. You're like, this is crazy stuff. This is too hard. Well, guess what? This is not even that bad. Okay, do not give up. Whatever you do, don't give up. You got to study hard, you got to have your notes, and you just got to take it one problem at a time. But the most important thing you can do here is really get great instruction. Okay, you need great, comprehensive, full explanation on this, because if you don't have detailed kind of a detailed understanding of the process and a clear, explanation and, example prompts, you're going to, it's going to be very difficult to understand. That's why it's okay to, if you're looking for assistance at this level, to get the little quick tutorials, but oftentimes they're missing a lot of details. When I teach, I really teach. I really, really, break things down into component parts. So this is just a little bit of a sample. But if this video helps you out, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.